Welcome to The Explainer. Today, we are diving deep into the high-stakes world of semiconductor back-end capacity planning. And yeah, it sounds super complex because it is. But it's hard. It's all about trying to create the perfect plan in an industry that, never, ever stops moving.
This sentence right here? This is everything. It's the core promise, the entire reason this whole complicated process even exists. And it is a massive, high-wire balancing act. You've got to deliver on time, get the quantity right, but oh yeah, do it as cheaply and as fast as humanly possible. You drop one of those balls and the whole system starts to wobble.
So what makes that balancing act so ridiculously hard? Well, the core challenge is trying to match this incredibly intricate, sensitive supply of semiconductors with a global demand that's, well, it's all over the place. It's volatile. And in this industry, getting that balance right isn't just a nice-to-have, it's a matter of survival.
I want you to think about it like this. The capacity planner is a conductor of a giant orchestra. They're not playing a single instrument themselves, but they are responsible for making sure every single section, from the machines to the materials to the people, plays its part perfectly and in sync. And they have to do all of this for an audience that might suddenly decide they want to hear a completely different song at any moment. That's the unpredictable demand.
So how do you even begin to tackle something that chaotic? How does our conductor get the sheet music for this symphony in the first place? Well, the answer is a strategic framework. It's a blueprint for success called capacity planning. Okay, so that's the textbook definition. But let's be real, what does it actually mean? It means you're basically trying to look into a crystal ball. It's about trying to predict what your customers are going to want in the future and then building the perfect factory today to meet that future demand. It's the master plan.
And these are all the different sections of that orchestra. You've got the internal stuff you can mostly control, things like how well your equipment is running or how well trained your people are. But then you've got the external curveballs you can only prepare for, like a sudden material shortage or, a global pandemic messing up the supply chain. The conductor has to manage it all.
So having a plan is one thing. That's great. But how do you really know if it's working? In this world, you can't just go by a gut feeling. You have to measure what matters. You have to turn those big, abstract goals into hard, cold data.
This is the question that should keep a planner up at night. Seriously, because finding the answer means you're moving away from guesswork and hunches and into data-driven reality. Are we fast? Are we efficient? Are we actually any good at this? The numbers you see, they don't lie.
Let's take a key metric, like equipment utilization. Seeing a number like 85% for productive time, man, that is music to a planner's ears. It means your multi-million-dollar machines, your most expensive, critical assets, are actually making things, not just sitting there collecting dust.
This is basically the planner's dashboard, and believe me, it is a constant tug of war. If you try to maximize throughput, you might see your quality, your process yield start to dip. Squeeze the cycle time too much, and you risk burnout and mistakes. OEE, or overall equipment effectiveness, that's the big one. It tries to bundle all of that tension into one single number. It's kind of like the ultimate score for the entire performance.
But even with the best blueprint and the most detailed dashboard, the real world is messy, right? The symphony doesn't always go according to the sheet music. So let's look at the common roadblocks that can throw even the most perfect plan into chaos.
First up, we have the classic fight, the plan versus reality. The spreadsheet promised you'd make 10,000 units. Awesome. But then a key machine breaks down, a shipment of materials is late, and bam, suddenly you've only made 8,000. That gap isn't just a number. It's a huge headache that sends painful ripples through the entire business.
Then there's this problem, inconsistent loading. Just picture it. One assembly line is completely buried under a mountain of work, running at 110%, people are stressed out, while the line right next to it is half empty, with people just waiting around. That kind of imbalance creates total gridlock. It's a recipe for bottlenecks and massive inefficiency.
This is all about people. It's what happens when the production team's goal to maximize output clashes with the maintenance team's goal to perform preventative repairs. And at the same time, management is just focused on cutting costs. When all these key players are pulling in different directions, you don't get a symphony, you just get noise.
And finally, we've got the silent killer, bad data. You've heard the saying, garbage in, garbage out, and it is brutally true here. If the data you're using to predict demand or measure your machine uptime is just wrong, well, your entire plan is built on a foundation of sand. It's basically doomed from the start.
Okay, so here's the crucial point.
These roadblocks, they are going to happen, they're inevitable. Winning isn't about avoiding them, it's about having the right toolkit to smash right through them, quickly and effectively. This is the big mindset shift. The best manufacturers, they don't just complain about problems, they attack them with specific solutions. You've got underutilization? Bam! You hit it with a robust maintenance program to boost uptime. Inconsistent loading? You counter that with a strategy that deliberately balances the workload. It's all about diagnosing a point of failure and turning it into a competitive advantage.
So, what does this actually look like in practice? It's a disciplined cycle. You start by deeply understanding your process and equipment, inside and out. Then, you use data to pinpoint the weak spots. From there, you bring in better systems and maintenance programs. But notice that final step, communication. None of this works unless everyone is on the same page, playing from the exact same sheet music.
And that leaves us with a final thought to chew on. We've been talking about the planner as this human conductor. But as artificial intelligence and automation get smarter and smarter, is the future role of the human planner still to conduct the orchestra? Or is it to design an AI that can conduct it perfectly, reacting faster than any human ever could? What does the perfect plan even look like then?